Welcome back to geometry. In this video, we're going to be talking about reasoning. But first, let's quickly review patterns. A pattern is something that follows a specific rule. There are two main types, number and visual. For example, a number pattern is 1, 2, and 3. This is because it involves numbers, as the name suggests, and also it has a specific rule, which is that it increases by 1 each time. On the other hand, there's something called a visual pattern, which involves objects. We have one circle, then two circles, then three circles. This is a visual pattern because it increases by 1 each time, same rule as the previous one, and it involves objects. These are two different representations of the exact same pattern. Now, why did we spend the first minute of a reasoning video talking about patterns? Well, it's because reasoning has a lot to do with patterns. Usually, reasoning is used to prove something about a pattern, and this something comes in the form of a conjecture. A conjecture is basically a statement we want to prove about a pattern. Let's look into an example. We have 1, 2, 3, a triplet called 1, 2, 3, a triplet called 2, 3, 4, and a triplet called 3, 4, 5. These are consecutive numbers, 3 consecutive numbers. Now, our conjecture is that the sum of 3 consecutive numbers is always divisible by 3. Here are a few examples of a triplet of consecutive numbers. How can we prove this? There are two different types of reasoning that we can use. The first one is called inductive reasoning, and the second one is called deductive reasoning. Let's talk about inductive first. Inductive reasoning is basically using examples to prove it. There are three main steps. The first step is to look at a pattern and see if it fits your conjecture. We see that the first triplet is 1, 2, 3. What's the sum of that? Well, that's equal to 6. The second one is 2, 3, 4. The sum of that is equal to 9. The third one is 3, 4, 5. Sum of it is equal to 12. Do these fit our conjecture? Our conjecture was that it's always divisible by 3. And all of these numbers, 6, 9, and 12, are divisible by 3. So it fits our conjecture. The second step is to modify the conjecture if needed. In this case, there is no need because it fits the conjecture. And the third step is to use logical reasoning to verify the conjecture. This brings us to deductive reasoning. Think of deductive as sort of like a detective. You're using logic and clues to solve the case. Well, that's exactly what deductive reasoning is. You're using logic, rules, properties, laws to verify the conjecture. Speaking of laws, there are two main laws that are used in deductive reasoning. The first one is called the law of detachment. And this basically says that if you have a condition and a result from that condition, so let's say we have something like, if the weather is good, I play basketball. The condition is if the weather is good, and the result is I play basketball. If you have a statement like this, and don't worry, we'll get into statements more in depth in the next video, but this is just a brief introduction. If we have something like this, and we know that this condition is true, then the law of detachment says that the result is always true. That's basically what the law of detachment says. And the second one is called the law of syllogism. Yes, it's pretty hard to pronounce, but it's called the law of syllogism, and it's very important because it says that if you have a condition and this result is a condition for another statement, then this statement is true. So that looks very confusing, so I'm just going to use variables now. Let's say we have a condition P and a result Q. Let's say we also have a statement with condition Q and result R. What this says, the law of syllogism, basically says that it's also true that if P, then R. This statement also exists with a condition of P and a result of R. That's basically like mashing up these two Q's together until we get P and R remaining. So those are the two main laws in deductive reasoning, but we can also use properties and rules and stuff like that. So let's see if we can use deductive reasoning to prove this conjecture. We can use variables to represent each triplet because we're trying to prove it for a general case, not just 1, 2, 3. So let's say it starts with x. Since we know it's 3 consecutive numbers, the second one must be x plus 1 because it's consecutive. And the third one must be x plus 2, again, because it's consecutive. And there must only be 3. So these are our 3 numbers. We want to find the sum of them. So x plus 1 is 2x plus 1. And we want to add x plus 2 to this until we get 3x plus 3. Well, since this is a nice expression, I'm just writing on the left side of the board now, so I have more space. We can factor out a 3. 3 times x plus 1 is equal to 3x plus 3. Now, x plus 1 is always going to be some sort of whole number because we're looking into whole number values of x, 1, 2, 3, and so on. So x plus 1 will always be a whole number. Now, when we multiply that by 3, it'll always be a whole number that's divisible by 3, because when you divide this number by 3, you'll still get a whole number. That's the definition of divisible by 3. Therefore, this proves our conjecture, because what we wanted to prove that this was that the sum is always divisible by 3. In this case, the sum, which is 3 times x plus 1, is always divisible by 3. Hence the proof. And that's basically reasoning in a nutshell. There's 2 main types, inductive and deductive. We use those to prove a conjecture. That's the entire video in a nutshell. So, thank you for watching. See you next time.